Welcome to the Explainer! Today, we are taking on a seriously high-stakes culinary mission, the precise synthesis of an Italian velvet mousse. We're going to look at the exact step-by-step protocol for fusing an Italian ganache with an Italian meringue. When you do this correctly, it creates this incredibly stable, velvet-textured masterpiece. I mean, we're talking about a dessert capable of holding incredibly sharp piped shapes, or even surviving high-heat applications like a baked tart or a soufflé. But as you'll see in just a moment, getting there requires treating your kitchen less like a bakery and a lot more like a science lab.
To achieve this structural marvel, we really must follow a precise protocol. We're going to cover 1. The impossible collision, 2. Phase I, ganache synthesis, 3. Phase II, temperature synchronization, 4. Phase III, kinetic integration, and finally, 5. Troubleshooting fatal mission failures.
All right, starting right off with Section 1, the impossible culinary collision.
Let's dive into the opposing forces we're attempting to force into a single cohesive dessert, because this really is the foundation of our entire mission. On one side, we've got the Italian ganache. Think of it as a heavy, incredibly dense fat emulsion. And on the other side, the Italian meringue, a fragile, delicate, air-filled protein matrix. We are literally colliding two extremes that naturally just want to destroy each other. If you just mash them together willy-nilly, the sheer weight of the fat will crush the air or the protein matrix will completely break the emulsion. So we basically have to outsmart the physics here.
Moving right along to Phase 1, ganache synthesis.
Our mission begins right here. Now, this isn't your standard chocolate and cream mixture. We are actually introducing a secret lipid weapon to stabilize our emulsion. Notice the crazy precision in the ingredient list. Standard ganache relies solely on chocolate and cream. But the Italian variant, it incorporates mascarpone. This is a cultured lipid that acts as a secondary stabilizer, and it provides that signature, luxurious velvet texture. So look at the precision required. Exactly 8 ounces of high-quality 70% dark chocolate finely chopped from a block. Absolutely no chocolate chips allowed. And that 1/4 cup of organic mascarpone, it must be strictly at room temperature.
The execution protocol for this phase is incredibly strict. You begin by placing your chopped chocolate and just a pinch of fine sea salt into a heat-proof glass bowl. Then, you heat your heavy cream in a saucepan to exactly 180 degrees Fahrenheit, which is about 82 degrees Celsius. You're looking for steam and small bubbles at the edges, definitely not a rolling boil. Once you hit that perfect temperature, pour the hot cream entirely over the chopped chocolate so it's totally submerged. And then, you stop completely.
Do not touch it. I repeat, do not touch it for exactly 60 seconds. This isn't just a casual suggestion, folks. Physics demands it. You absolutely must allow the thermal energy of that 180-degree cream to deeply penetrate the cocoa butter matrix and initiate the melt on a molecular level before you introduce any kind of kinetic friction. Patience right here is absolutely critical.
Okay, so once those 60 seconds have finally elapsed, it's time to create the friction emulsion. Grab a rubber spatula and begin stirring in tight, fast circles, but only in the absolute center of the bowl. Don't go scraping the sides yet. Keep your focus dead center until a glossy, dark core forms. As that core establishes itself, you can slowly widen your circles, pulling in the unemulsified cream from the edges. Once it's perfectly smooth, you go ahead and fold in your room temperature mascarpone until the whole shebang is completely homogenized. Next up, Phase 2, temperature synchronization.
Now we face the most critical and honestly most perilous step of the entire protocol, synchronization. Both the Italian ganache we just synthesized and our pre-synthesized Italian meringue, which, just as a quick reminder, is egg whites whipped with 240-degree invert sugar syrup, must be resting precisely in this calibration zone. They both need to be between 95 and 100 degrees Fahrenheit or 35 to 38 degrees Celsius. This is the absolute sweet spot for integration.
So, what does this all mean? Well, understanding what happens if you miss this Goldilocks zone is key because it results in immediate mission failure. If the ganache is too cold, the moment the meringue hits it, the fat seizes up into literal culinary concrete. No way to fix that. On the flip side, if the ganache is too hot, the excess thermal energy violently melts the microscopic protein walls of your carefully whipped meringue, turning your entire dessert into a useless puddle of soup.
Now, to verify this calibration manually without relying entirely on a thermometer, you can use the touch test. Just feel the bottom of both mixing bowls against your inner wrist. The metal or glass should feel neutrally warm to your skin. It shouldn't feel perceptibly hot, nor distinctly cold. When both bowls feel identical and totally neutral, boom, your components are mathematically synchronized and ready for contact.
All right, moving to Phase 3, kinetic integration.
We have our perfectly tempered components. Now we have to combine them mechanically without crushing the delicate air structures we've worked so hard to build. And remember, whatever you do, you cannot whisk these together. We initiate integration with something called the sacrificial scoop. You take exactly 1/3 of your fluffy Italian meringue and drop it straight into the warm ganache. And then you whisk it vigorously. Yep, you are intentionally destroying the air bubbles in this first scoop. Why on earth would we do that? Because the ganache currently has a specific gravity that is simply way too high. It is way too heavy to accept the fragile meringue. This sacrificial scoop bridges that massive density gap, lightening the chocolate base so it can actually welcome the rest of the foam.
So, with the specific gravity lightened, we had the second third of the meringue, but we completely change our kinetic approach here. Switch to a wide silicone spatula and execute the precise J-fold. You cut straight down through the center of the bowl, scrape along the bottom toward your body, and gently fold the mixture over the top, basically tracing the shape of a J. Then you rotate the bowl 90 degrees and repeat. This genius little move preserves the trapped air while mechanically integrating the fats and proteins.
Finally, you add the final third of the meringue and continue that super gentle J-fold just until no white streaks remain. But the absolute second you see a uniform color, you must obey this command. Stop immediately. Overfolding is incredibly dangerous here, folks. The excess friction will literally knock out all the remaining trapped air. If you ignore this warning, you won't get a cloud-like mousse. You're going to end up pulling a dense, rubbery brick out of your fridge later.
Okay, on to our final section, troubleshooting fatal mission failures.
Because let's be real, even with the absolute best preparation, things can go horribly wrong in the lab. Let's analyze the 2 fatal defects you might encounter and see if they can actually be salvaged. As you fold, you constantly need to be visually assessing your mixture. You are looking to avoid 2 distinct disasters. First, the grainy or broken defect, where the mixture suddenly looks separated and greasy, weeping actual oil. Versus the soup failure, where you are left with a flat, liquid puddle that completely refuses to hold its shape.
Let's break down that grainy defect first. The root cause here is temperature loss. Your ganache dropped below 88 degrees Fahrenheit, or 31 degrees Celsius, probably while you were busy making the meringue. At this temperature, the cocoa butter actually begins to crystallize. When you fold the meringue in, that solidifying fat acts like thousands of tiny blades, literally shearing the protein walls of the meringue, breaking the emulsion and weeping oil. The correction? Well, if you catch the ganache cooling too much before integrating, you can save it. Just place it over a double boiler for a quick 10 to 15 seconds to return it to that safe 95-degree fluid state. The soup failure, however, that has a much darker prognosis. If your mousse is a liquid puddle, you basically committed one of 2 errors. Cause 1, you executed the J-fold way too aggressively and physically popped all the air bubbles. Or cause 2, you added the meringue while the ganache was over 120 degrees and the intense thermal energy simply melted the foam right into a liquid. The correction for the soup failure? Yeah, there isn't one. The structural integrity is permanently destroyed. But hey, if you respect those temperatures, honor that 60-second melt, execute the sacrificial scoop, and master the gentle J-fold, you are going to synthesize absolute perfection. Now that you've mastered the intense physics and precise synchronization of this protocol, you're armed with the knowledge to create an almost indestructible dessert. So, I'll leave you with this. Now that you know the science, what shape will your velvet mousse take?